everybody. So I'm Erin Lemky, and I'm going to talk to you today about how automation can be the efficient cartographer's trade secret. To give you a little bit of background on who I am, I have worked with Safe Software for 11 years, and it was founded 25 years ago by Don Murray and Dale Lutz, who some of you may have met. Actually, I think, Roger, you've met them as well, personally, because the company started here in BC helping the forestry industry as they exchanged maps with the local government to meet regulations, and they used the SAIN format for that exchange, SAFE, and so that's actually where our name comes from. So this might actually be how you recognize them from back then. They haven't marketing team yet, but good job. They're very proud of their booth.
Don and Erin.
Yeah. So the story goes that it was 11 o'clock at night and the bid was due at midnight and they needed a name to incorporate, and so they checked if safe.com, S-A-F-E, was available, and it was, because it was 1993. But the reason they put in a bid for software instead of services was because they recognized that it was a real problem for local companies to exchange information or integrate data together. It was technically possible, but with lots of coding and lots of effort, and a lot of information was lost. And so even today, their mission continues to be to help organizations maximize the value of data, and that's reflected in the software offering that we provide, FME, Feature Manipulation Engine. And so it's a data integration software with the best support for spatial data in the world, even still today. And the idea is that you can do it without coding. You can obviously extend it to code if you want to, but the idea is to make it really easy and accessible for everybody with a GUI. They still foster a culture of giving back, both in their philanthropic, I knew I'd say that, it's good that, with all their efforts and donations and everything, but they also offer a lot of grant program licenses and stuff. So those of you that are thinking, I don't have funding, I'm not getting any value out of this presentation, I'm hoping to give you a lot of value regardless of whether you use our tool or not, first of all, and secondly, if you are a student or a post-grad, or you're doing research, or you work for a nonprofit, there are grants available. So most of my coworkers, to go back to the other slide, they work out of this new office here, which is in the Tech and Innovation District in Surrey. There's 175 of them there. A few of us work remotely. I work right here in Prince George. I've been here for 7 years. And we also have a global presence, so we have about 150 organizations that are partners with us that offer the services, because we are just a software provider. So hopefully you'll get a lot of ideas just from that background, where we see a lot of different things that cartographers are doing, and GIS people, for those of you that are GIS in the room, that we see all the different ways that people are using automation to make their work more efficient and get the project goals met as fast as they can and as cost effectively as they can. And so what I'll talk about a little bit today is I'll talk about some of the common challenges we see the most. I'll focus in a little bit on a few of them. I'll talk about data quality, transformation, of course, is a big one, actually delivering the map, and then I'll leave you with some resources and support, because ultimately, Roger was asking, is 20 minutes enough to talk about this topic? And of course, you could spend a whole career looking at it, but hopefully I give you some ideas that you can take home with you. So the most common challenges that we see in our work is data integration, for sure, right? The basis of everything is, what is your source data set? Do they work together? Is the data model compatible? And how does that work in a practical sense? And then making sure that the data that you're working with for your source, so that you can build a beautiful, useful map, is of high quality, so that that end output is useful. And then transformation, of course, you're looking at scaling or generalization, things like that, it becomes very important. If you are using some sort of automation to actually build that end output, or at least the beginnings of that end output, styling can be very important. And then, of course, the actual delivery of the map, whether that's printed or digital. So I'll start with an example of a real use case. This is going on right now, so the project isn't finished. This is actually the only picture I'm allowed to show, so I guess everything else is still in progress. But this is Hans van der Merel, one of our partners in the Netherlands. He's working with a public bus route data set. And basically what they were doing is they'd hired a bunch of cartographers, and they were trying to put this information into a really useful map where they were using parallel lines instead of overlapping. And they were showing the thickness of the lines would show the importance of the route, or the frequency of the route. And they were finding that it was taking a really long time. So they decided to use automation And so what they did is they took now the KML files that have the bus routes that include the colors and everything, and they output them as an MIV or MIF file, retaining that color from the KML. And then they imported it on top of a base map using Avenza's map publisher, which is a GIS and cartography extension for Adobe Illustrator. And then what that did is it saved about 50 or 60% of that prep time, but then they were still going to apply all their cartographic skills at the very end. So they did some manual cleanup, but it took them most of the way there, and it's saving them a lot of time in the output. So to speak to some of the challenges we were talking about and how you could solve them, integration, this is an interesting slide for those of us at SAFE, because it's interesting that because we're very responsive to what our customers need, we can kind of see how the data types that have been available to GIS and cartography have happened over time, and really the trends that we've seen. And so it really started out here with CAD and GIS, those forestry stories I was telling you about, local governments and things like that. And over time, now I'm sure most of you work with databases, rasters, point clouds, and things like that. Is anyone in the room visualizing information in gaming engines? I doubt it. You are? You are? That's awesome. Let's talk later. So we just released in 2019 support for Unreal Engine. And so because I understand, I haven't read the legal myself, but I understand that the licensing that Unreal offers is actually free unless you're actually selling a game. And so there are people in the AEC or architecture, engineering, and construction industry using it to visualize new builds and things like that, where you can actually immerse yourself in the environment. And then indoor mapping I'll touch on a little bit. Of course, AR and VR, and machine learning is becoming important as well. When it comes to data quality, it's really important to understand and validate your data and see, are there any errors in it? How accurate is it? There's a lot of different techniques you can use. For example, you can take a look at spikes like those that are shown on the contours on the screen, right? We want to fix those. Are there intersecting errors or intersecting contours? Because if they do, there's an error. Overlapping areas, validate the geometries, check attributes, and check connectivity like a flow network, which I'll get into in a moment. But really, to make sure that you have good quality, you really need to have granular access to the features, because if you understand the geometries and attributes, that allows you to extract reasonable results, even if the data quality is, I don't know if I should say bad, but not what you need. And so, for example, if the CAD data is not structured properly by layers, or if symbology is set randomly, for example, an annotation in a CAD file could make a break or a hole in the line, and that could be repaired with automation for different annotation rules. So let's take a look here at some examples of generalization. So here, generalization could be pretty simple, just reduce the number of vertices. But if you're not doing that carefully, it can lead to the wrong depiction of reality. And so before simplifying the data, from going from one scale to another, for example, you can enrich the features with knowledge about themselves and their surroundings, and that can prove helpful. So I'll stop painting all of you with that terrible example on the side and show you something that's much more useful. So with a smart generalization, you can see that here the red constraints did not allow simplification because otherwise the points would be on the wrong side. And the blue shows the new area, or the lines that were drawn, and then the green is the original. And this one was actually, if you're a user of FME, this one was done using the Sherben transformer, which was developed for NRCan about 10 years ago. We had a whole bunch of cartographic challenges that they were facing, and we built some transformers specifically for them and then put them in the main product. So for those of you that do use FME, I would encourage you to use our ideas forum in the FME community and suggest things, because things that are upvoted often do end up in the product. So some more examples where automation could help with generalization would be things like lengths or areas, keeping only those that are long enough or big enough, or enlarging those that are significant within a threshold. Whether a feature is on the left or the right of another feature, so for example, a house in a river or a gas station in a highway, and I'll show you an example of one of those later. Spatial relations, of course. And then now we'll just take a closer look at that example on the screen. So this is an FME workflow. It's a relatively complex one. I don't know if Don would agree to it. He always says try and keep a workspace under 10 transformers. But what we're doing here is we're taking islands, rivers, lakes, and countries up there, performing some enrichment calculations and making decisions like, we are a small group of islands, or I am a small island really close to a big one, or I am a big island, and then we're performing smart generalization and writing the output to map info with styling. And then on the bottom you can see that we're taking bridges and roads, finding where they meet, and then placing correctly rotated symbology in those locations. And then of course there's circularity, deciding what kind of labeling that could be used. So if we compare Sweden and Poland, you can see that because Poland has got a very round shape, it makes sense to use your standard horizontal label. But if a feature is elongated, it's better to follow its shape. So those kinds of things can be automated. And then we'll talk about that river flow that I promised you. So this one's kind of a fun story because it's from my colleague Dimitri. He's our scenario creator. And he tells the story of when he was taking cartography in post-secondary in Russia. And that was back in the days when everyone was hand-drawing everything. And he says his professor gave him the assignment where they needed to represent how rivers flow, not their actual width, to teach the students this common problem. And he says it's a lot easier with automation today because you can perform the calculations to not only discover this information, but also represent them automatically in the output. So you can determine the stream order by calculating the appropriate river width and make them flow. And more functionality you can automate for the stream order would be keeping short but significant rivers, because you can't remove even the shortest river, obviously, if it disconnects an important lake from the ocean. So in the examples here on the left, Dimitri would have failed his course, and on the right, he would have passed with an A. So then, of course, there's displacement. And here's an example where, let's just see here. There we go. Here's an example where, something that can be really easily automated. So it enables you to display features like roads, highways, and railways without having those features overlap. So this example is taken from the Pine Pass, just north of here, near Powder King Ski Resort. But now I'm wondering what the original name for this area is. And I didn't have a chance to look it up at lunch, but I'm very curious. So then, of course, for amalgamation, you don't want to distort representation. You can't simply delete small islands because that will distort the look of the area. So this image shows the impact of different amalgamation parameter values as we simplify the coastline and merge parts that are close to each other. So there are a lot of other types of transformations you can do automatically. So for example, you can reproject to a different coordinate system. You can scale, which we've talked about complexities when it comes to generalization and displacement and other challenges that can be automated. You can replace geometries, so for example, go from areas to points to represent a city, and then you can snap so that the road still goes through that city now that it's just a point. You could densify, you could have visual properties like the hillshade map that you saw a moment ago, and you can also make new features such as bigger administrative units, city blocks from curbs, and buffer center line by street status. So for example, here you can see local showing thin and pale lines are represented, and then for regional, wide and bright. So when it comes to styling, I'll just touch on that really briefly. I know there's a lot of different ways people are using automation and building your maps as an output. So if you are wanting to style your maps in a digital way and in an automated way, you can do things like smart labels and line styles and things like that. And so in this example, what was done was smart labels, line styles, transparencies, and raster overlay operations were applied. And then the output was written as a raster image, outputting the results in Mapnik. And so Dimitri did this one as well, and he used the Mapnik rasterizer transformer, which is a way to produce nice raster map outputs. And it enables you to take any source data that FME can read and then perform customized styling, which is done using the Mapnik library. So then here's an example that kind of combines some of the stuff we were doing. In this case, amalgamation is used just temporarily to apply smart labeling. For those of you who are using FME, I wanted to point out IndexMap is a custom transformer created by someone in the FME community. And so you can use it to generate frames and legends and things like that. I would encourage you to check that one. Check out the FME Hub, because that's where people can exchange different things that are useful to them. So we have different levels of publishers. Safe Software Official is the ones that are coming from us that we guarantee will be updated with each release. And then we have Lab and Sandbox for things that are either not guaranteed to be aligned with the release or just for fun because we wanted to. And then of course there's community level as well. So when it comes to delivering maps, here's another example from Hans. He was asked to create bike route maps. So when you're generating outputs, you're picking your format for output. So it can be vector, raster, PDF, Adobe Illustrator, web-friendly, raster tiles, printed maps, that kind of thing. And in this case, he was using printed maps. He was inputting geotiffs, so he was mosaicing them together, and then had to cut over 500 sections for bike path routes. You guys know bikes are really popular in the Netherlands. And so he took base maps and vectors, and then he wanted to make sure things like the rest stops were on the correct side of the road. And so here you can see how automation was helping your cartographer take information that already existed and used automation to prepare it for the end user of the map. Here's another one. So this is my colleague, Holly Coxton. She actually came to us from Sterling Geo, which was a utility in the UK. And what they had is it would be quiet for a while, and then all of a sudden she would have a whole bunch of requests for maps. And people like engineers that worked with her that would go out on site, they would need to be inspecting substations and things like that, power lines, and they would need that information from her. So she automated the process and replaced that manual package creation with an automated process where she could just cut out the vector products, the ordnance survey, open map data that was a source, and supply them out as a PDF. And incidentally, we also have a PDF reader. So if you're taking, I saw some interesting things this morning where you're looking at old paper maps, you can digitize them by reading them in and give yourself something to kind of start with. And then PDFs can also be an output, but there's a lot of different options. It could be Illustrator and try it that way. So when it comes to map delivery, the trend we're really seeing at SAFE is that mobile is just becoming more and more and more popular. And indoor mapping is a new trend as well that we're starting to see. Looks like, oh dear, I'm missing a slide. Okay. I was going to tell you, actually, before I talked about indoor mapping, I was going to tell you about Tessera Systems, so I'll have to show you later if you're interested in seeing this. But they were doing, they're a geoinformatics and machine learning and web and cloud geoprocessing company based in Calgary with a primarily remote workforce. So I actually met their colleague Dwight Wolf here at the Raster Talk actually a little while ago at UNBC. And he was telling me about this story and connecting me with his colleague Michael and how they're helping forestry clients derive business information from satellite imagery, LiDAR, and ground plots. And they're using FME to create a high-resolution inventory service they're calling HRIS. It covers 10,000 square kilometers and turns raw data into more manageable tile project data used within its machine learning software and into a slippy map tile and vector tiles within its online bureau. So I was planning to show you that, but it didn't make it in here. So the automation also is interesting because it only requires a few little parameter changes in order to work with the next client, which saves them a lot of time. But to talk about indoor mapping then, what we're finding is that we've mapped a lot of the outside world, and that is not going away. We're all continuing to do tons of that, but we spend 90% of our time indoors, which is terribly sad, but it's true. And navigating large spaces like airports is becoming very important, especially things like airports where you don't visit very often and you really are on a time crunch to find your flight. And so big airports and small airports are all starting to solve this problem with indoor mapping on apps or web maps and things like that. So YVR, Vancouver International Airport, I was talking to Carlos there in the GIS department. They're delivering their data in IMDF, which is the new Apple standard for Apple Maps and other apps that are built for iOS, as well as a web map using GeoJSON and some other outputs as well. And so is Schiphol, and you can actually see how they're using AR as well in their app to try and sell you a scarf. And then finally, I just want to talk a little bit about how mapping is also helping human health. So they're using GIS technology to help with things like at Oxford Eye Hospital. They're looking at how disease changes the eye. So they're checking how effective treatment is. They're looking at mapping the patient's vision so they can see how that changes over time and what the patient can see. And then BC Cancer Agency and Neurotech are partnering with us. We're working on a research project right now to see how automation and machine learning can help simulate tumors, identify tumor location and size, detect changes in these, and then help with better targeted treatment. and the research is currently focusing on brain tumors. So if you're interested in any of that stuff, let's connect and talk more about how we can work together on that. So we've talked in a really quick way about integration, data quality, transformation, styling, and map delivery, and all the different ways that you could use automation to save some of your time and make things more efficient. If you want some more ideas and resources, there's these are hour-long webinars. We've got something that's specific about cartography and our product. We've got stuff about map text labeling and MapMig, and then we offer all these free resources and support that you're welcome to check out later. So thank you for listening.
Do we have any questions for Erin?
I've got a comment.
Comment?
Some people have heard me say this before, but the very first GIS users group meeting we had in '96, and the thing I heard over and over from our members was, we don't know what we did before SAFE and FME. And my response is, well, I remember what we did. I paid $500 to a Seattle company for a DOS text file, which was called trim2dxf.exe. So I don't know why a Seattle company did it. You took the BC data, converted it into AutoCAD, which then ArcInfo could read. So it seems like a stone age ago now. But, everyone's impressed with what they've done with this software.